So, we will continue our discussion on error analysis. So, yesterday I have discussed some of the aspects. So, whatever this error analysis I am discussing, and today also I will continue discussion. So, mainly I will refer on book which is very good book, and you can consult with this book. So, this that book is basically here I have given this. So, basically an introduction to error analysis by John R. Taylor. Okay. So, this from this book mainly I am teaching about the error analysis. So, you can get this book. Basically, this book will be available. I think this from Google search you will get this book, digital books you will get. So, today I will discuss about the types of error. So, when we do experiment, so what are the types of error we face? So, it is basically first type of errors is illegitimate errors. What is that? Errors that originate from mistakes or blunders in measurement or computation. Okay. So, these very careless errors, okay. So, that may happen, and that very easily you can find out this type of error from your result, because this error is will be obvious from the incorrect data points or results. So, that then you can find out the reason for this error and repeat the experiment to avoiding those errors. So, these are very careless errors. So, that is we tell these illegitimate errors. So, it's not under the analysis of the error, okay, because this error no way this result is correct. So, you cannot accept the result. Okay. So, you have to just throw these results and you have to do the experiment again. Okay. And but before doing experiment you have to find out what is the reason for that. Okay. So, this one reason I can tell you this, you have written you are supposed to write say in centimeter unit, but you have written in millimeter unit. Okay. So, these are very broad gross errors, this obvious error, okay, that only you will find out from your incorrect data points or incorrect results, and then if you pursue the reason for that. So, they will find out. So, some this obvious mistake you have done, as for example, as I told, in place of centimeter you have written millimeter. So, during calculation, so you have considered this unit millimeter. So, 1 order of magnitude this that is error, it will obviously affect your data points and result. So, that you can nullify easily repeating the experiment. Okay. Then next type of errors is systematic errors. So, what is that? So, from the name you can from the name you can tell that the errors associated with each data throughout the measurements in the same way is called the systematic error. Okay. So, this type of error is associated with each data and in the same way. Okay. So, then this is the systematic error, and due to this error the results are shifted in one directions. Okay. So, I will give you example that or what are the sources of these systematic errors. So, that obviously you can find out. So, this source of systematic errors generally it can be due to faulty calibration of the instrument. Okay. What does it mean? Faulty calibration of instrument. Say you are using ammeter or voltmeter. Okay. So, their scale is given 1 volt, 2 volt or between 1 volt, 2 volt there are smaller divisions, right. Now, so someone calibrated this voltmeter ammeter, and if that calibration is wrong, that means whatever here 1 volt it is showing, if you use another voltmeter or ammeter, so then it is showing say it is 1.2. Okay. So, this 1.2 should be the accurate one, but your meter it is showing 1. Okay. So, this faulty calibration basically will affect your all datas. Okay. So, this another type of systematic error could be this bias on the part of the observer. What does it mean? Bias on the part of the observer is so when you are taking reading, so you are supposed to take reading just you see your eye, you have to just in perpendicularly you have to put your eye with the scale. Okay. But you are taking reading from this side or the other side. Okay. So, then whatever reading you will see, so if you take this reading systematically, so you do not know that you have to take perpendicularly. Okay. You have to set your eye perpendicular to the scale, but you are all the time that is your probably habit or whatever you are or this you are thinking that you are in perpendicular position, but somehow you are tilted. Okay. So, that way your all data will be affected because of this your position, because of the position of your eye. Okay. So, this again so this will be propagated in all data points. Okay. So, there is a basically, so your if you plot these data points and if you know the true value of the curve or true curve you know, and if you plot your experimental data, then you will see your data may be very good, but you will see this overall there is a shift of this whole data. Okay. So, so from there obviously you will find out okay, this is because of some error. So, that basically you have to find out. Now, here it is very difficult to find out. Repeating the experiment will not help you to find out this error or to minimize this error, because if you use the same faulty calibrated instrument, if you take the data in same way from sidewise, so okay, so you will get the same result again and again. So, that is why we tell this type of error are not easy to detect and not easily studied by statistical analysis or repetition of the experiment. Okay. Repetition of the experiment. So, this but you can identify this the systematic type of error, and how to nullify that one. So, that you have to find out. So, it is not easy to find out, but you have to try to find out this type of error and nullify it, or what we do, we know this is a systematic error, reason I could not find out. So, just we shift this data, just we shift this data. So, we remove this offset, So, for that way also we correct this data to nullify this systematic error. So, then last this very important error, this called random error. So, name again, this name is telling this is basically statistical error. It's randomly occurred in each data. So, to improve the error, so only way the repetition of the to minimize this error is the repetition of the measurement is the only way to get better result. So, this random error is very important error, and mainly we will concern about this random error in our laboratory, because this is in our hand to minimize it. So, mainly repeating the experiment we can minimize this, and yes. So, this is the error we will discuss in details. So, when we do experiment or study experimental physics, then one obvious question is this, or we use these two terms, one is accuracy and another is precision. One is accuracy and another is precision. So, what is accuracy and what is precision? How to distinguish these two terms? What is accuracy? Accuracy of an experiment is a measure of how close the result of the experiment is to the true value. So, how close our experimental result to the true value. So, if difference between this true value and this measured value, experimental value are very close, then we tell this accuracy of our experiment is very good. So, that is why we define the accuracy. Then what is precision? We usually tell we have to measure precisely, our instrument is very precise, and we did the experiment very precisely. What does it mean? So, the precision is a measure of how well the results have been determined without reference to its agreement with the true value. So, you did experiment very carefully, that is called very precisely, without bothering the agreement with the true value. So, this is the precision. So, this precision is also a measure of the reproducibility of the result in a given experiment. So, if you repeat the experiment, then all the time you will get more or less same result, same kind of data. If you get, then this called the reproducibility. You can reproduce your data, you can reproduce your result by measurement in many times. So, if you get the same result, same data, then we tell the reproducibility of your experiment is very good, and that we express in terms of the precision. So, the precision of the experiment is very high. So, that way we express these terms precision. So, this basically uncertainty in measurement determines the precision of the experiment. So, how this the experiment will be precise? So, that we can determine basically through the uncertainty in the measurement. Okay. So, that means uncertainty and precision are related. Okay. So, precision of the experiment depends on the precision of the instrument which is expressed by the least count. Okay. Precision of the instrument we expressed by the least count. So, and this precision depends on this precision of this least count. That means, so this precision of the instrument that we express in terms of least count, and that is what this least count we take as a uncertainty. So, thus the precision is related with the uncertainty. Okay. If your uncertainty is smaller and smaller, means least count is smaller and smaller, then automatically precision of the experiment will be higher and higher. Okay. So, this uncertainty or error in the measurement of x, y, z, if it is del x, del y, that is why this del x, del y that we take which is equal to the least count LC, least count. Okay. So, as I told this I was discussing this just using when we are writing the result. Okay. So, some x best value plus minus delta x. Okay. What is delta x? So, that I told I will tell later on. So, this delta x is basically is related with the precision of the instrument, and this delta x, delta y, etc. these are equal to the least count of the instrument which is used to measure this parameter x and y. Okay. So, now when we are doing experiment in the laboratory, basically our aim is to find out some quantity, physical quantity. Okay. So, that physical quantity in the most of the time we cannot measure directly. Okay. If we can measure directly, so then least count of the instrument which is used to measure that quantity. So, that will be the error or uncertainty in the measurement. Okay. But unfortunately, that does not happen all the time. We have to measure one or more quantities, okay, and then the physical quantity which is related with this all these measured quantity with some relations, okay, and then basically from this measured quantity and from this relation we calculate the physical quantity of our interest. Okay. So, final result whatever we are getting of a physical quantity. So, this is not from a direct measurement, it is basically calculated from the relation of many parameters, many quantities which are measured, and for each quantities there is a error uncertainty. Okay. So, now question is what is the uncertainty? What is the uncertainty in the calculated quantity? What is the uncertainties in the calculated quantity which has well relation with measured quantity as I described. So, this is the question we have to answer. Okay. That means, I know the uncertainty or error for each quantity which I measured, and now I have calculated the some physical quantity which is related with those measured quantity. Now, what will be the error of this physical quantity, that we have to find out. Okay. So, so this we tell the basically propagation of errors, and how to find out the error of the final quantity. So, that is what we will discuss. Okay. So, this physical quantity, it has some relation with the measured quantity, right. So, relation either it is this sum of the measured quantity, okay, or difference of the measured quantity, or multiplication of the measured quantities, or division of the measured quantity. There will be relation with the physical quantity of the measured quantities. Okay. So, as I told, either some difference or multiplication or division. Okay. So, in this form it is this, there will be relation between these two between the physical quantities and measured quantities. Okay. So, so here in step by step we will find out the rules how the error propagate from measured quantity to the physical quantity, which will be calculated. Okay. So, here when there is a sum or differences in the relation. So, these two parameter here x and y, okay, and physical quantity is q, So, this is the relation summation or this difference. So, this physical quantity q is related with the measured quantity x and y, or this x and y two measured parameter, and this physical quantity q, there is a relation either in summation form or difference form. Okay. So, if so, then what will be the error on q? So, for error on x I know, error on y I know. Okay. So, x I have measured. So, x we expressed as x base plus minus delta x, y is y base plus minus delta y, right. So, then q equal to basically we have to express q base plus minus delta q. Okay. So, now we want to find out this delta q, error on this q. Okay. So, then we can write this basically if you take this summation form. So, then x based q equal to x plus y, x is basically x based plus minus delta x plus y based plus minus delta y. Okay. So, this I can write x based plus y based plus minus delta x plus minus delta y. So, why I have written this? Because this x based plus y based, then plus, either this can be plus it can be plus delta x plus delta y, plus delta x minus delta y, minus delta x plus delta y, minus delta x minus delta y. Okay. So, there are 4 possibilities. Okay. So, among them, among these 4, what will be the largest value of q? Obviously, this x based plus y based plus delta x plus delta y, and smallest value of q will be this minus this x based plus y based minus delta x plus delta y. Okay. So, this is the largest value of q and this is the largest value, smallest value of q, and that depends on this part. Okay, on this part. So, so q based is equal to x based plus y based, and this then delta q this basically error, this delta q. Okay. So, we can write as a plus minus del x plus del y. Okay. Del x plus del y, what does it mean? So, basically this error we define this lower limit and upper limit. So, this data will be, this value will be between these two limit. Okay. So, this so from here we got that this when this plus, then it is the largest value, when it is a minus, then it is the lowest value. So, this limit is taken, will be taken as a this error delta q. So, that is plus minus del x plus del y. So, what does it mean? What does it mean? So, here basically in case of sum, here we can tell that this error on this quantity q, okay, it will be just this summation in summation of the error of x and error of y, right. Error of x is delta x and this delta y. So, summation of this delta x and delta y will be the error on q, and obviously that is plus minus. So, from this summation we got this one. Let us see this difference if this x and y this is related with the physical quantity q, it is like this q equal to x minus y. So, same way if you proceed, so q is q base plus minus delta q equal to x minus y. So, x base plus minus delta x minus y base plus minus delta y, right. So, this we can write x based minus y based, this is the q based, this is the q based, okay, plus from here I have written here plus plus minus delta x, and here I have written minus plus delta y, right. So, what would be the largest value of q? So, obviously this value best value x best minus y best plus delta x plus delta y, here also 4 possibility, okay. Here also 4 possibility. So, this I think this same 4 possibilities, okay. So, this among these 4, these 2, so for these 2, one is plus and one another is minus of the summation of the individual error. So, that will give me the largest value of q and smallest value of q. So, 2 limits of the value of the q. So, then in this case also this error is basically coming as a summation of the individual error. So, so for summation and difference, in both cases the error of the physical on the physical quantity will be the summation of the individual error of the parameter x and y. Okay. So, I think yeah, then I will discuss this I think this. So, in general we can generalize this result, okay, because for summation and difference we saw the error will be on the physical quantity which is calculated, and if it is related in summation or difference form of the measured quantity or measured parameters, okay, then we found that the in both cases error will be the just summation of the individual errors of the parameters. Okay. So, we can generalize this these findings. So, then here just for rules, this now rules is for summation and difference. If several quantities x, y, etcetera, z, u, v, etcetera, w are directly measured and the calculated quantity q is related with this x y z u v w like this. Okay. So, here the summation is there, also this difference also there. Okay. So, then error in directly measured quantities is that we know from the measurement and least count of the instrument. Okay. X base plus minus delta x, etcetera, etcetera. Okay. So, then now what is the error in Q? So, error in Q is Q base plus minus delta Q, and that delta Q will be just summation of the individual error on x, y, z, u, v, w, right. So, error in computed value of Q is the summation of all original errors associated with the directly measured quantities. Okay. So, this one rule we could find out for the propagation of errors. So, then we will discuss I think next one I can discuss, just I can take one examples to show it. So, here just I have two liquids in flask. Okay. So, this liquid, it has weight say m1, m1 is the weight of first flask and liquid. So, weight of this one liquid and this flask is m1, capital M1, and then I will just throw this water and then take the weight of the empty flask. So, this is smaller m1, okay, mass of first flask empty. Then I think I should show you. Okay. So, similarly m2 and for this one m2 and capital M2, capital small m2. So, this value say here 540 plus minus 10 gram, small m1 is 70 plus minus 1 gram, okay. M2 is 960 plus minus 20 gram, M2 is 130 plus minus 1 gram. Okay. So, now what is the total mass of liquid, that is what if we want to find out. So, that obviously this mass of the total mass of liquid M is M1, if we add them together, okay, these two liquid. So, what will be the mass of this liquid? So, this is M1 minus small m1, that is the liquid mass, plus M2 minus small m2. Okay. So, this is the mass of the second liquid. Okay. So, this 1300 gram, that is the mass of the liquid. So, now fine, this is the my result. Now, what is the error on it? So, that I have to find out delta m. Now, this is the relation, it is a summation and the difference. Okay. So, rule I know. So, this error on this capital M will be the just summation of the individual errors. So, delta M1 plus delta small m1, delta capital M2 plus delta small m2, and their error is given plus minus, here is 10, 1, then 20, then 1. So, 10 plus 1 plus 20 plus 1 equal to 32 gram. Okay. So, final result, then we can write the total mass of the liquid is 1300 gram plus minus 32 gram. Okay. So, here basically you can just round off. So, this 1300 gram plus minus 30 gram 30. So, instead of 32 grams generally we write this 30 gram. Okay. So, So, because these two have no because error is 32 itself. So, these two 32 and 30 it says within error. So, we round it off and better to write 30 gram. If you write 32 also, it's not harmful, but it's but these are the well representation. So, this way just one can find out the error of the parameter of or quantity of interest. Okay. So, I think I will stop here. I will discuss this product and questions in next class. Thank you for your attention.